In this second part of the review, we will look at 13 through 20. So these are some things with complex numbers. First, the first two, actually really the first four, have to do with graphing complex numbers or recognizing numbers on the complex plane. So number 13, we have -1 minus 5i. So remember, the -1 tells us where we go on the real number line, which is the horizontal one, actually even labeled here. So we go left 1, and then the second number tells us where we go on the imaginary, so that's -5, so we go down 5. So -1, and then down 5. There's our point down there, so this is -1 minus 5i. Same idea for number 14. Actually very much the same because we have that -5i again, but this would be left 4, and then down 5. So there's the point -4 minus 5i. And now 15 and 16, we are just going to identify the complex number. So on number 15, we see it way down at the bottom of our graph. Well, to get there, that's 1, 2. We're at 2 on the real number line, so that's 2. And then we are down 5. So 2, we're going down 5, so 2 minus 5i. And number 16, very similar, except so we're over 2, but this time we're up 5. So this is 2 plus 5i. Pretty straightforward for graphing. Just make sure you go the correct direction. All right, for 17 through 20, we learned, so we could graph them and we drew a right triangle and used Pythagorean theorem, but then we learned if we have the absolute value of any complex number, it equals the square root of a squared plus b squared. This seems like a very straightforward formula, and it is. There's a few mistakes people make sometimes, so make sure when you square things, it does help to put them in parentheses, because if it's a negative that goes there, a negative squared is a positive. Sometimes people get mixed up with which sign this is. It's a plus because it does relate back to the Pythagorean theorem, a squared plus b squared. And the other thing, there you do not put an I in there. It's not a squared plus bi squared. It's just a squared plus b squared. So I'll try to reiterate those things as we work through here. Once we find the answer, we do need to put it in simplest terms, or simplest form. So this is simply going to be the square root of 10 squared plus just 2 squared. Don't put the I in there. So this is the square root of 100 plus 4, which is the square root of 104. Now we need to simplify that. I'm recognizing that 4 goes into that number, so we can write this as the square root of 4. And if you need to, you can pull out a calculator. 104 divided by 4 is 26. So the square root of 4 times the square root of 26, which is 2 times the square root of 26. All right, number 18. Number 18, this is the square root of -3 squared. Make sure you put the -3 in parentheses, plus 4 squared. It's not 4i squared, it's just 4 squared. We should be able to just do this in our head. -3 squared is +9 plus 16. Another mistake I see sometimes, people try to take the square root of 9 and then the square root of 16, but you add the 9 and 16 first. So this is the square root of 25. And that's a nice easy one. The square root of 25 is 5. Number 19, same idea. The square root of 2 squared plus, it's always a plus, -3 squared. The -3 goes in parentheses. We don't use the I. So this is the square root of 4 plus -3 squared is 9, 4 plus 9 is 13, so we have the square root of 13. The square root of 13 is prime. It cannot be simplified any further. And then number 20, same thing. Square root of 9 squared plus 3 squared. We don't use the I. 9 squared is 81. 3 squared is 9. So we have the square root of 90. We need to simplify that if possible. Well, 9 definitely goes into 90. 9 is a perfect square. So this is the square root of 9 times the square root of 10. And the square root of 9 is 3. So we have 3 times the square root of 10 is the absolute value of 9 plus 3i.